Hi, hello, ఎలా ఉన్నారు మీరు అందరికీ? Hi, hello students, good evening all. Am I audible and visible? ఒకసారి చెప్పండి. Hi, hello. Hi, good evening Spandana. So, ఈరోజు capacitors. And we'll be finishing it in one class, okay? Chalo, good. So let us see. Just give me a minute. And let us start. Okay, great. Sure. Good. So how is the energy, everybody? Yes, Pandana, very good. Kerala Chari, very good. Rashmita, hi. Shalini, hi. I'm good, Shalini, I'm good. Yes, I'm good, everybody. So let us start. Yes, good evening. Hello, everybody. Good evening. Very good evening to all of you. And this will be the one shot in the capacitors by me. Okay. So start chedam andariki cheppandi okasari. Like cheskondi. Everyone like the video first of all. Like it and let's start it. Good. So students, I am trying to keep this chapter as basic as possible. Okay, basic until let's start from again the potential and potential nunchi. Let us jump to this chapter again, Mali. Okay. So, sir, let us start. Good. Okay. So, potential gurinchi maatladtam re. Hi. Everybody, hi. Very good morning, very good afternoon, whatever it is. So let us talk about potential, sir. What was the potential we discussed in the last class? Electrostatics has been done, kada? So electric potential is nothing but the work done per unit charge in moving it from place A to place B. Ante kada? Yes, sir. Very good, sir. I have one thing to tell you, sir. What is the thing, Ray? Chuskondi. If at all I am having an electric field, Ray. Chuskondi andariki. Arey, what is electric field, sir? Okay. So the energy is very high, ante kada? Yes. So, sir, let us discuss first of all potential as the work done on the charge by the external agent. So, I want you to imagine a system, Ray. How many students are watching? First of all, let me check it. Good. 14 watching, but 4 likes only. Ray, 14 watching, Ray, and only 4 likes, Ray. Like cheskondi andariki. Okay. Good. So, sir, I have a region in which I have the electric field, Ray. How is the electric field varying, Ra? So let us say na daggara oka capital charge Q is there, and do I have one more charge small q, Ra? Cheppandi andariki. So if there is a distance r between them, what is the force between the two charges? Cheppandi andariki. What is the force between these two charges, sir? Sir, the force between two charges is equals to K Q1 Q2 divided by R square. Ante kada? Yes. This is the force between the two charges. Okay, sir. Now, what I have to do is I have to bring this charge from this point to another point Q. Let us say this is the second point, Ra. So I have to bring this charge from this point to this point. Ante kada? So 2 points. Point A is there and position B is there. Andarki chuskondi. What will we say, Ray? We'll simply say that na daggara 2 positions untundi, position A and position B, ante kada? And I have to bring that charge from position A to position B. But in presence of external. Yes, very good. Praneeth, very good. Yes. Okay. So this charge has to be brought from point A to point B. Kani, there is an external field also, Ray. External field due to capital Q charge. Ante kada? Yes. So, sir, I have 2 different points, point A and B, and I'll simply say potential at point B minus potential at point A is equals to work done by the external agent. So, there is this external agent who is pushing this charge slowly, ante kada, towards this capital Q charge. So work done by external agent divided by the charge Q. You remember this formula, all of you. Remember this formula only. Very good, sir. Very good. So, what can you write, sir? Work done by the external agent is equals to Q into delta V. But, this is only work done when the electric field is present or any electric charge is present. So, let us take a question, sir, then. Okay. The question says something like this. Choose koni andarki. If an electric field of E is equals to 10 I cap Newton per coulomb exists in space. Full stop. Find work done in a charge of magnitude 4 coulombs from point A to point B as shown. Chuskondira as shown. So, sir, idina electric field in the right side kada. What is the value of electric field, sir? What is the value of electric field? E bar is equals to cheppandi 10 times of I cap. Ante kada. What is the relationship between electric field and electric potential? Andarki cheppandi. Electric field and electric potential ra. What can I say? So, let us say these are the 2 points, sir. Idina first point, point A, and this is my first point, point B. Ante kada. This is my first point, point A, and this is my first point, point B. Ante kada. Good. Sir, potential is equals to integral negative of A into dx. Right? What is dx? Dx is the small displacement. And you substitute the value of electric field. So, it is integral of minus of 10 into dx. But the limits is starting from, okay, I'll also give you the separation between the two. So, let us say it is 10 meters. Cheppandi. So, sir, it is equals to 10 into x. Kani, the value of x is 10 meters. Kada? Yes. So, sir, 100 volt is the potential difference. 100 volt. Good evening, good evening, good evening. Very good, very good, very good. Very good, very good. So, sir, potential is 100 volt. But, ante what do you mean by potential? So, we are considering the two different places, kada. So, sir, VA minus VB modulus is equals to 100 volt. What is work done by external agent? Sir, W is equals to Q into delta V. Q into delta V. Ante kada? Yes. What is the value of charge? Charge ki value cheppu 4 coulombs. So, it is 4 coulombs multiplied by cheppandi. What is the magnitude? Magnitude is 100 only. Ante kada? So, that is equals to 400 joules. So, idi now work done as by the external agent. Okay. Very good, Kerala. Very good. Next. Chuskondi. Should I take a question only? Not question actually. So, let us say statement. Chuskondi. So, if this is my charge, Q is equals to 10 coulomb. Andariki chuskondi. And if there is one more charge, let us say small q is equals to 2 coulomb placed at a distance of 10 meter. Cheppandi. Potential due to capital Q at 10 meter distance. What is the potential? Sir, potential is equals to KQ by R. Ante kada? So, when I am telling you the potential at a given point, that is senseless. Potential at a given point is senseless. Why? Because there is nothing as absolute potential at a given point. When we are talking about potential, we always talk about potential difference. Potential is a relative terminology. Sir, potential is a relative terminology. Ante kada? Yes. Ente entira. That means whenever we are talking about potential, we are talking about the potential difference between 2 points. We are talking about potential difference between 2 points. Kani. Usually, the first point is assumed at infinity. We are assuming the first point as infinity. So, sir, when I'm talking about V, it is not V. When I'm talking about V, it is potential at a given point P minus potential at infinity. Sir, what is potential at infinity, sir? We assume potential at infinity is equals to 0. It is our assumption. What is infinity, sir? Infinity is malli oka relative terminology. Infinity is a relative terminology. Andariki ardham cheskondi. So Vp minus V infinity is kq by r. Ante kada. So that means work done in bringing this negative or this 2 coulomb charge from infinity to the given point is equals to potential at point P ante kada. That is equals to kq by r. Eppudu చూసుకోండి అందరికీ చూసుకోండి. ఇట్స్ అ వెరీ ఇంపార్టెంట్ క్వశ్చన్, వెరీ ఇంపార్టెంట్ ఫార్ములా ఆల్సో రా. చూసుకోండి చూసుకోండి. సో ఇమాజిన్ ఇది నా ఫస్ట్ స్క్వేర్, దిస్ ఇస్ మై సెకండ్ స్క్వేర్. ద చార్జ్ ఆన్ ద ఫస్ట్ స్క్వేర్ ఇస్ ప్లస్ క్యూ, ద చార్జ్ ఆన్ ద సెకండ్ స్క్వేర్ ఇస్ ప్లస్ 2q రా. రేడియస్, దీనికి రేడియస్ ఇస్ r1, ఎక్కడ ద రేడియస్ ఇస్ r2 అంతే కదా. సార్ వాట్ అబౌట్ పొటెన్షియల్ సార్? వాట్ అబౌట్ పొటెన్షియల్ రే? Potentials are different. చూసుకోండి ఎక్కడ వచ్చి the potential at the surface of the sphere. ఏంటి ఫార్ములా సార్? పొటెన్షియల్ ఫార్ములా is kq by r1. ఎక్కడ వచ్చి సార్ what is the potential సార్? Potential is v2 is equals to k into 2q divided by r2 అంతే కదా. when I'm touching them ఎప్పుడైనా you are touching the two conductors, always remember that the net potential on them becomes the same. Touch chesi potential same aitadi ante kada. Very good. So sir, as soon as I am touching them, so how is the potential coming out to be same ra? Koncham charge, it will flow from one sphere to another sphere. Are you understanding? Chuskondi. So when I am touching these two spheres ra, so what happens is, out of this 2q charge, some charge, let us say x, it is coming on this charge sphere ra. So it q plus x ante kada. So initially it was q, x has been received, it becomes x q plus x. Ekkada initially it was 2q, x has been lost, it became 2q minus x ante kada. So now let us talk about the potential. Andariki cheppandi potential, radius is r1, radius is r2. So v1 it is equals to v2 ante kada. v1 is what? K times of q plus x divided by r1 should be equals to k times of 2q minus x divided by r2. Right? Yes. So sir, what is q plus x sir? What is q plus x sir? Charge on the first sphere. Can I simply say charge q1 and q2 are the final distributions ra? Charges q1 and q2 are the final distributions. So what can I say sir? Potential 1 is equals to potential 2 ante kada. Sir, k q1 by r1 is equals to k q2 by r2. K gone. Cheppandira. So what can I say? q1 by q2, it is equals to r1 by r2. Ardhamaindi? So what you can say sir? If I have two spheres in contact, the ratio of the charges is equals to the ratio of the radii. Ante. So you have to calculate the value of the charge kada. Yes, final charge distribution ra cheppandi andariki. So what can I say from here? Sir, q plus x divided by r1 is equals to 2q minus x divided by r2. Cross multiply cheyandi sir. Sir, it becomes q into r2 plus x into r2 is equals to 2q into r1 minus x into r1. Ante kada. Pappendira. Send this side, send that side. Cheppandi andariki. So sir, x into r2 plus x into r1 is equals to 2q r1 plus q into r2. Oh. So you take out x common, right? You are getting r1 plus r2 kada. Yes, is equals to q also common, right? 2r1 plus r2 kada. Yes, very good, sir. So you can simply say x is equals to q into 2r1 plus r2 divided by r1 plus r2. So this is the value of x that flows from one sphere to another one. Are you understanding? Are you understanding? Next tray. We are going to talk about capacitance. I hope you have a good understanding of potential. If you don't understand potential well, you might be facing problem in understanding capacitance also. Biryani. What biryani? Who is eating biryani? Okay. What is capacitance, sir? Capacitance is simply defined as the amount of charge that could be stored at a given potential. Ante kada. So you can simply say capacitance of an object or system, capacitance of an object or system is defined as the capacity, the capacity to hold the charge. The capacity to hold the charge at given potential. Oh, sir, what a definition, sir, what a definition. So capacitance is equals to the capacity to hold the charge. Now there are two objects are there. This can hold more charge, this can hold less charge. So I can say, sir, the capacitance of this charge is more, this charge is less. Ante kada? Oh, hi. Chal. So the question is, not the direct question. Let us derive the formula. Capacitance is usually represented by the letter C. Capacitance is equals to charge stored per potential. V is for potential, not speed, not velocity, not volume. It is potential. Very good. C is equals to Q by V. Ante kada? So sir, let us take a question then. Na దగ్గర ఒక sphere ఉంటుందిరా. A sphere of charge, a sphere of radius r has a charge q. Full stop. Find the capacitance. Cheppandi andariki. Find the capacitance. Ante na దగ్గర ఒక sphere is there. A sphere lo there is plus q charge, but the radius is r kada. I have to talk about the potential. Capacitance. How will you write it? Sir, capacitance is equals to q by v, sir. Sir, q by v, sir. What is q, right? Q is q only, sir. What is v, right? Speed of the sphere kada. V is the speed of the sphere. V is the speed of the sphere. V is not the speed, ray. V is not the volume, ray. V is the potential, ray. Potential. What is the potential on the surface of the sphere? Cheppandi. What is the potential on the surface of the sphere? V is equals to kq by r, ray. Kq by r. What is k? K is 1 by 4 pi epsilon naught kada. Oh, yes. So ante 1 by 4 pi epsilon naught q by r idi na voltage. Potential. Lift, shift. Cheppandi. So you can C is equals to Q divided by V value ra cheppu 1 by 4 pi epsilon naught Q by R. Q gone. Everything comes up. Capacitance is equals to 4 pi epsilon naught into R. అర్థం చేసుకోండి. Is this capacitance depending on the charge? చూసుకోండి రా. Is this capacitance of the sphere depending on the charge? No. Is it depending on the voltage? No. What is it depending on? Right? What is it depending on? చూసుకోండి. Epsilon naught R. What is R? What is R? Radius of sphere. Oh, so that means the capacitance of the object is only dependent on the dimensions. Only on the object ray and not on the charge ray or not on the charge ray. చూసుకోండి అందరికి. Very good. So the capacitance is only dependent on the system only, not on the charge, not on the potential. Oh, now I got it, sir. I will write. Capacitance is a hardcore property of material. Oh, sir, the capacitance is a hardcore property of material. It does not depend on any other factors, how much charge you are giving, how much potential you are giving. Understanding capacitance of the object, it is the hardcore property of the material only, property of the system. Ante kada? Yes. So sir, రకరకాలుగా capacitance ఉన్నాయి రా. So we're not talking about all of them. There are spherical capacitors, there are cylindrical capacitors. Sir, capacitor ante enti ra? Capacitor ante enti ra? Sir, capacitor is the condenser. Alright? Condenser. I think I have heard the name, right? What is condenser? Right? What is condenser? Sir, the condenser is used in fans. Oh, the condenser is also used in coolers. Yeah. The condenser is also used in cameras. Oh. అర్థమైంది కదా? అర్థమైంది. అరే, how many of you have traveled in train ray? What happens? You have to, push this fan, then and only then it starts kada. But that doesn't happen on your regular fan. Why? Because there is capacitor on the fans in your house, and in the railways the capacitor is gone. That is why you have to push it by your finger and then it starts. Ante kada? So what is the role of the capacitor? Okay? What is the role of the capacitor? Chuskondi. Capacitor is used in appliances where we need a big chunk of energy in a very short interval of time. Have you seen the camera? When you see the flashlight, small flashlight is there, but when you press it, how much brightness it does? Are you understanding? So you see the camera, very small light kada, for a very short interval of time, it creates a big spark kada. Yes. Similarly in fan also, capacitance stores the energy. Capacitor stores the energy and releases it when it is required. Ardham cheskondi. Capacitance, yes. Very good evening, Kanmani. Very good evening. Capacitor. Okay. Capacitor is what? Capacitor is nothing but it is the source of energy. Ante circuits lo what happens is we need immediate amount of energy at some times. So ela store cheyali, dani kosam we use the capacitors. So capacitor ante enti ra? You might have seen these small capacitors in your charging circuits also ra. In cameras it is there, in fan it is there. Capacitor is also known as condenser. Chuskondi. If you have heard the name, you go to an electrician's shop, akkada velli cheppandi, sir, I want the condenser. He will show you what the condenser looks like. Okay, so a capacitor or a condenser is used in a circuit where we need immediate amount of energy in a very short interval of time. You imagine as if it is an energy source ra. So what does the capacitance do? In normal time, it stores the energy exactly like your power bank. Exactly like your power bank. What does power bank do? stores the energy, and when it is required, it delivers all of it. Kada? Same thing. Same thing the capacitor also does it. Same way. So what does it do? It stores the energy, and when required, it gives massive amount of energy in a very short interval of time. Ante kada? Good. 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 So now we have to see capacitors. Are rakarakaluga unnayra chuskondi. So types ante you can simply say you have spherical capacitors, but they are not there in our syllabus, okay? But spherical capacitors are there. Chappandi. Number 2, you have cylindrical capacitors. It is not there in your syllabus, okay? Okay, cylindrical capacitors. It is not there in your syllabus also. Chappandi. Number 3, chappandi. Parallel plate capacitors. Are, is it there? Is it there? Is it there? Yeah, yes. It is there. So we are going to discuss about parallel plate capacitor. Sir, what is the prerequisite, sir? What do I have to know before starting parallel plate capacitor, sir? You need to know Gauss law. You need to know Gauss law. Electrostatics law. Gurtunda, what did we discuss? We discussed that if you have an infinite sheet, and let us say the charge density of this sheet, cheppandi, if sigma is the charge density, what is the field rate close to the sheet itself? Cheppandi, a place lo electric field ki value ante enti? How many of you remember the field due to infinite sheet? Cheppandi andariki. What is field due to infinite sheet? Is sigma is the charge density ra. Cheppu andariki. What is the electric field? Electric field gurinchi matladu. Classy is the... So sir, the electric field direction ante away from the sheet. ఎందుకంటే పాజిటివ్ ఛార్జ్ ఉంది కదా. సో పాజిటివ్ ఛార్జ్ అంటే the field lines are away from the field. Okay. An electric field can simply be given as sigma by 2 epsilon naught. Arey chudandi andariki chudandi. So this is the electric field due to an infinite charged sheet. Ante kada. Now I am doing one thing, re. What I am doing now, re. Chuskondi. I am going to place one more sheet, re. So this is my second sheet. Now I am giving it a negative charge. Cheppandi andariki. Negative charge unte, what do you think is the field value, ra? Same thing. Sigma is the charge density. Ade. Sigma is the charge density. Chepp, what is the field value and direction kavali nagu? Cheppandi andariki. So you can simply say, due to this negative sheet, the field is directed towards the sheet only. The field is directed towards the sheet only. And what is the value? What is the value? Again, sir, value is sigma by 2 epsilon naught. Oh. Until if I am bringing two sheets together, negative sheet, positive sheet, negative sheet, positive sheet. Ante kada. So field at a general point, field at a general point, cheppandi, directed towards this side. Due to this and due to this, cheppandi andariki. Okay, cheppandi. So the net field due to both the plates is in the same direction. Same direction low net field unte, what can you say, sir? We can simply add the two fields kada. Oh yes, you can add it. You can add it. So add chesina tarvata, what you get is, so if you have two plates, infinite plates kept one after the another. How should I write it? So I will write something like this. Chuskondi. Ante kada. So these are the two plates, these are the two plates, and the net field is E net is equals to E plus E ra, sigma by 2 epsilon naught plus sigma by 2 epsilon naught ante. So What is the conclusion? What is the conclusion, sir? Conclusion is only this. If you are talking about the net field at any point between the two sheets, if you are talking about the net field between any of the two sheets, what is the net field? Cheppandi andariki. So if you are talking about the net field between any two sheets, so these are the two sheets, చూసుకోండి, right? Not like this, right? Not like this, yes, like this, like this. So these are the two sheets, kada? So take a general point between the two sheets, right? Here. Take a general point between the two sheets. This is a positive charge, this is a negatively charged field. Cheppandi, at any general point, what is the value of electric field, right? Sir, sigma by epsilon naught. Sigma by epsilon naught. Ante kada? And what is the direction, right? What is the direction? Direction is always towards the negative charge. Ante kada? Negatively charged sheet, right? So if this is my positively charged plate, right? And ide na negative charge plate, ante kada? So the net field will be directed towards negative charge sheet, and value gurinchi maatladalante, so you can simply say net electric field is sigma by epsilon naught. Ante kada? Yes. Listen now. I am trying to link up everything, okay? I am trying to link up everything. Andariki chuskondi. Re. Okay. Yeah, cheppandi. What is the doubt, ray? Ray, what is the doubt, ray? What is the doubt, ray? What is the doubt, ray? Hi. Good evening, Darkan. Good evening. Hi, Ahan Edits. Hi. Hi. Okay, so let us revise once again, Ray. Chuskondi. If you have a sheet ante telusa, if you have a sheet, plate, metallic plate, a plate lo you're charging it. So if you have a plate, metallic plate, and let us say there is this positive charge given to this plate, andariki chuskondi. How much charge are you distributing? You can't say. Endukante it is an infinite sheet kada, so it can hold infinite amount of charge, but I'm only interested in charge per unit area. Charge per unit area. I'm calling this as in sigma. Okay, I'm calling it as sigma. Chuskondi. So if there is charge on the sheet, there is definitely going to be electric field. Ante kada? If there is charge on the sheet, there is going to be electric field, and the direction of the electric field we calculated in electrostatics. Gauss law. Okay, Gauss law. So the electric field near the sheet, the direction is away from the sheet for the electric field. And what about the magnitude, ray? Sir, magnitude is simply sigma by 2 epsilon naught. So this is the mottam work for the positive sheet. Ante kada? Ippudu I am talking about negative sheet. Cheppandi andariki. So if this is my negatively charged sheet, cheppo. So if this is my negatively charged sheet, again the same charge density sigma. What will be the field? So field gurinchi maatladalante, the field will be directed towards the sheet in all the directions. Chuskondi. Ekkada vachi the field will be away from the sheet at all the points. Ante kada? Yes. Ekkada the field will be directed towards the sheet, ray. Are you understanding? So emaitadira? If I am bringing these two sheets together, what do you think will happen? Cheppandi. So if I bring the two sheets together or very close to one another, idena positively charged sheet. Cheppandi andariki. Re chuskora. And if this is my negatively charged sheet, cheppo. So what do you think, Ray? This is my negatively charged sheet. So I want a field at a general point. Okay, general point ki I have to calculate the field. Cheppandi, what is the field, Ra? So E sheet valla the field will be sigma by 2 epsilon naught, and the same field having the same direction will be sigma by 2 epsilon naught towards right also. So I am talking about any general point. Our general point low, there will be field due to both the sheets kada. Yes. What is the value? What is the value? Hi. Hello. What is the value of net field? So sir, you can simply say net field is equals to sigma by 2 epsilon naught. This is due to the positive sheet. Ante kada? This is due to the positive sheet plus again sigma by 2 epsilon naught. Kani this is due to the negative sheet. Andariki ardham cheskondi. If you are not understanding now also, if you are not understanding now also, will focus here. Focus. Okay. All I need is focus. Little attention. Hi. So net field entira. So the net field is equals to sigma by epsilon naught. I am not going to repeat it again and again. Okay. So na daggara two sheets unte, this is positive sheet and this is my negative sheet. Ante kada? Yes. So this is my negative sheet. So sir, దీంట్లో ఒక పాయింట్ తీసి I have to talk about the field on that point. I just did re. Field is sigma by epsilon naught. What about field? What will you do by calculating field? It's of no use for me. Understanding? It's of no use for me. Are you understanding? But when you talk about potential, that is a useful thing for me. So potential is a very useful tool. Kani electric field not a useful tool for me. But I can definitely jump. I can jump to potential from electric field kada? Yes, I can. What is the formula for potential in electric field, sir? Sir, the potential formula is given as Chapura, what is the potential between field and relation between field and potential? What is the relation between field and potential? Chappu andariki. Sir, potential is given as integral of what? Integral of field with respect to displacement. Integral EDX ra. Simple formula. Are you understanding? Good. Okay. So directly E into dx ra. Cheppandi E into dx. We are starting from the first sheet and going to the second sheet. Let us say the distance between them is d ra. Andariki chuskondi. I want all of you to understand, okay? So the setup looks something like this. Rendu plates unnai. Distance ante d is there between the two plates. Area of each plate is A. Andariki ardham cheskondi. Area of each plate is A. Distance between the plates is D. And electric field is sigma by epsilon naught. Now integrate cheskondi, but I am traveling from first sheet to the second sheet ra. Andariki ardham cheskondi. So these are my two sheets. Ante kada? So these are my two sheets. I am traveling from first sheet to the second sheet. How much distance do I am traveling? How much distance am I traveling? D. Distance between the plates. D. I am traveling the distance equals to D. Are you understanding? So the initial position for me was 0. Are you understanding? Because I was at this plate only kada. I was at this plate and then I am traveling to this plate. Sir, what is the initial distance? 0. What is the final distance? D. So the limits of integration should be 0 to D. Ante kada? So E into dx. E is a constant value ra. So constant unte remove it and throw it. Ante finished. So you can simply say E into integral dx 0 to D. Ante kada? So that is equals to E into D only re. You got the value re. Potential value re. You got the potential value re. Okay? So potential value is V. What is the value of E re? What is the value of E ray? E is sigma by epsilon naught. E is sigma by epsilon naught. So sir, sigma by epsilon naught into D. Oh ho 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 ho. I got the value of V also ray. I want to calculate capacitance, right? So capacitance is calculated simply as Q by V ray, and even that also I got V ray. I only need Q now. Ela calculate cheyali ra Q. Ela calculate cheyali చూసుకోండి. Sigma is what ray? Sigma is చెప్పండి. అరే చెప్పండి రా చెప్పండి. Sigma is areal charge density. Areal charge density. అంతే కదా? Yes, yes, yes. So ఇక్కడ నుంచి you can simply say sir sigma is equals to Q upon area ray. So ఇక్కడ నుంచి what you can say? Q is equals to sigma into area. Oh, I got Q also ray. I got V also ray. I got Q also. I got V also. I got Q also. I got V also. Arre, the substitute ray. It's a very easy thing to do now. What to do now? Oh, what to do now? AM cheyali ra. Arre, sir, capacitance is equals to Q by V, sir. The initial formula I told you. Q ki value enti ante sigma into A divided by V value enti ante sigma d by epsilon naught. Oh, yeah. So sigma d by epsilon naught. Arre, this is capacitance, right? Arre, this is capacitance. Eppudu em cheyali? Arre, reverse it. Reverse it. Basic mathematics kada? Yes. So sir, sigma into A into epsilon naught divided by sigma into D. Ante kada? Oh, nice. That means sigma sigma gone. Gone. Ante kada? So capacitance is equals to epsilon naught by D. Right. Perfect. This is me capacitance. Okay. So quick revision. So if at all you have a capacitance, or not capacitance, parallel plates, okay? Parallel plates, you charge them opposite charges. Positive charge, negative charge. Distance between the plates is D. Area is A. What is the capacitance? What is the capacitance of this system? ఏముంటుంది చెప్పండి రా. Very good. Jyoshna Reddy, very good. So sir, capacitance is simply equals to A epsilon naught by D. Or why am I getting confused, right? Sir, you said the capacitance depends on the charge and potential. We wrote the formula na re. Chusko. C is equals to Q by V ante kada. So sir, you can directly see capacitance is dependent on Q, and you can directly see capacitance is dependent on V. But in formula we are not getting Q by V. Nare. Why re? Why? Hi Spandana. Hi. Hello. Why we are not getting Q and V? So that means the capacitance is not dependent on charge, and the capacitance is not dependent on V also, right? Yes. The capacitance is the hardcore property of the material. Capacitance is the hardcore property of the system or of the material. Okay? Ardhamaindi? So capacitance does not depend on whatever charge you give it. So sir, if I have neutral plates ante enti ra? So sir, if I just have these plates and I don't charge them, sir, if I just have the two plates and I don't charge them, I just keep them very close to one another, can I say about their capacitance? Yes, you can still talk about their capacitance. Ardhamaindi? Are you understanding? It is not required to talk about the charge and the potential. Epadaina you are bringing a system together, it automatically decides its own capacitance. I hope you are understanding. Chuskondira. Similarly, if I am just bringing two spheres together, metallic spheres, even without giving the charge, they together will decide their own capacitance. Are you understanding? So how much charge they will store at a given potential, it is only dependent on them ray, not dependent on charge not dependent on the potential also. Are you understanding? Good. 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 Next. Next, let us talk about some questions. So, again I am revising the formula. Okay. Again I am revising the formula. Malli okkasari chuskondi andariki. So, మీ దగ్గర two parallel plates ఉంటే the capacitance of these two parallel plate is A epsilon naught by D అంతే కదా? Right? 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 Good. Question. Find the capacitance చూసుకోండి. This is my first plate ray and this is my second plate ray. Okay. So let us say, sir, these are connected to a battery. Not battery, not also required that ray. That's also not required. Okay. So let us say the distance D is equals to 10 meters. Okay. The radius is equals to 7 meters. Cheppandi. Option number A, option B, option C, option D. What should I write? Option A is 10 epsilon naught. Option B is 2 epsilon naught. Option D is 3 epsilon naught. I want option C to be correct option. So, Meeru cheppandi, what is the correct answer? I want to fill that in option C. Cheppandi andariki. What is the capacitance? Capacitance re. Capacitance re. Capacitance gurinchi cheppandi. What is the formula for the capacitance, sir? What is the formula for the capacitance, sir? So the capacitance is equals to the capacitance is equals to epsilon naught by D. A ante area. A ante area kada? Yes. D is what? Distance between the plates. Shape chuskondi ra. What is the shape? Shape is circular. Area is pi r square. Substitute pi into r square into epsilon naught divided by D. Ante kada? Yes. 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 Oh, nice. Nice. Good. Hey. Chuskondi here. Good. So, sir, capacitance is equals to pi into epsilon naught into r square. Ante kada? Divided by D. I have two ways. I do have two ways to calculate the capacitance. What is the first way? Direct substitute the value of R and D, you get in terms of epsilon naught. So, sir, that is equals to pi into R square ante 7 square. Pi ki value ante 22 by 7 ante kada? So, capacitance is equals to 22 by 7 into R square into epsilon naught divided by D is 10. So, 7 gone. That is equals to 154. Ante kada? So that means 77 by 5 epsilon naught. Alright, this is my first option. So you can simply say 77 by 5 into epsilon naught. Ante kada? Oh yes. Good. Kani, there is one more way. I can find actual value of capacitors. I can find actual value of capacitors also. Cheppandi. Sir, the capacitance is equals to pi r square into epsilon naught by D capacitance rate. So you can simply say pi epsilon naught into r square by D. Pi epsilon naught. What is pi epsilon naught? It is something, I can recall something. What is pi epsilon naught? 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 Cheppandi andariki. What is pi epsilon naught? I am able to recall pi epsilon naught. 1 by 4 pi epsilon naught. K. Oh, nice. So K is equals to 1 by 4 pi epsilon naught. What is the value of K? Sir, 9 into 10 to the power 9. Yes. So 9 into 10 to the power 9 is equals to 1 by 4 pi epsilon naught. You send it this side. So 36 into 10 to the power 9 is 1 by pi epsilon naught. Reverse re. You got the value of pi epsilon naught is equals to 1 by 36 into 10 to the power minus 9. Lift, shift, ante. So 1 by 36 10 to the power minus 9 r square 7 square 49 by 10 ante kada. So it comes out to be 49 by 36 into 10 to the power minus 10. Oh, this is the actual value of the capacitance. Nothing to do the calculations. Are you understanding? You don't have to do the calculations. The only thing is common sense, which is not so common. Okay. Next. Okay, let's take some PYQs. Okay, now I think this much is more than sufficient for you to understand everything. Okay. So చూసుకోండి. The question. రే అందరికి చూసుకోండి రా. Right, PYQs with this color. So the question is the capacitance of a capacitor. So, sir, the capacitance. Capacitance is what, sir? Capacity to hold the charge. Q by V. Okay, alright. So C is equals to Q by V ante kada. Capacitance is dependent on the charge also. It is dependent on potential also kada. Good. So you can simply say, sir, Q and V both, right? It depends on charge and potential both. Wrong. It does not depend on charge and potential. I told you earlier also, we got two different formulas for capacitance. For sphere, for parallel plates, A epsilon naught by D, 4 pi epsilon naught into R. It depends on the geometry of the capacitor, not on charge and potential. Okay. Good. Good. Next, చూసుకోండి. We'll see some of the questions. Okay, some more questions. So question number 2 is find the ratio of capacitances C1 by C2 is equals to what? So this is my first plate, AD na second plate. Okay, separation is D ray, area is A ray. Okay, so capacitance here is C1. Andariki చూసుకోండి. ఎక్కడ వచ్చే capacitance is C1 ra. And in the second scenario, the area is A by 2. And here also the area is A by 2. And the distance is 2D. Capacitance C2. చెప్పండి. C1 by C2 కి వాల్యూ ఏమొస్తుందిరా? Okay. Yeah. Sunny, I don't know Sunny, who you are, Sunny. But Promotion is banned here, okay? If you promote something, it is banned, it is banned, it is banned. Okay, promotion is banned, right? Hey, Chapandira, what is the value of C1 and C2? For C1, for C1 is equals to A epsilon naught by D. Chapandira, area is A, epsilon naught is epsilon naught, D is D. Ante kada? Ekkada cheppandi. C2 is, what is area? Area is A by 2. Oh, nice. Epsilon naught is epsilon naught. D is 2D. It is coming out as 1 by 4 A epsilon naught D, and this is C2 1 by 4 C1. C1 by C2 is equals to 4 by 1. Ante kada? Good. Not 3 by 2, Ray. It's not 3 by 2, it's 4 by 1, Ray. It's 4 by 1, Ray. So, we take different plates, different combinations. You can simply say it is R1, it is distance as D1. Second case lo, radius is R2. Here also, the radius is R2, the distance is D2. Cheppandi. Capacitor value entira. Sir, C1 by C2 is A1 epsilon naught by D1 by A2 epsilon naught by D2. Gone. So, you're left with A1 by A2 into D2 by D1. Ante kada? Cheppora, what is area? Pi R1 square by pi R2 square into D2 by D1. Gone. So, it is R1 by R2 whole square into D2 by D1. Finished. So, this is the ratio of the capacitances of the board that I wrote. Yes, Ahan edits. What is your doubt? Cheppo. What is your doubt? Ask valid doubts only, okay? Don't ask something that is irrelevant, okay? Okay. Okay. So this is the question. Cheppandi. Apple, ball, cat, dog. Apple, ball, cat, dog. Apple, ball, cat, dog. Good. Aro, very good. Reduces by half. I will not going to tell this answer, okay? Not every question is to be told, Ray. Not every question is to be told, Ray. Next, let us talk about the energy stored in the capacitor. But before that, circuit. Circuit ante entira? So if you have a resistor, light is a resistor? Yes. Fan is a resistor? Yes. TV is a resistor? Yes. Your cell phone on charging, is it resistor? No. Is it? Is it? No? Hi. Re, Kesava Narayana, re, focus. Okay. So, what I'm telling, Ray? I'm telling you, resistor is a light, yes. Fan, yes. But how we show it? In circuit, we show resistor something like this. It is a resistor. But capacitor, sir, how do we show capacitor? Hi, Isha, very good evening, Isha. So how do we show capacitor? We show it simply like this. Oh, this is the capacitor. Yes. And if I connect it to a battery, how does it look? How does it look? Okay. So, this is a capacitor and this is a battery. Oh, nice. Choose kondi. Where is the positive terminal of the battery? Where is the positive terminal? The longer stick or the shorter stick? So this is the positive terminal. It is a negative terminal. And this plate will get a positive charge and this plate will get a negative charge. Ante kada. Ardham cheskondi andariki. Is it correct? Is it correct? Is it correct? Okay. You're not talking to me at all. Okay. Hey, Sunny, why are you saying sorry? What happened? What did you do? What did you do? Chapo. Okay. So this is the positive plate of the battery. This is the negative terminal of the battery. So can I say positive charge will run from this, negative charge will run from this? Can I say that? Can I say that? Can I say that? Hey, I don't know. Chuskondi andariki. Okay, darken, very good. So, sir, in resistance, sir, we applied the formula. What formula did we apply? 10 volt battery, sir, 2 ohm resistance, sir, current. What formula? Ohm's law. Gurtunda? Ohm's law. I is equals to V by R, kada? Okay. V 10 R 2 and 5 ampere current here. Nice. Good. Very good. Same thing. 20 volt battery. Resistance was given to you, right? Resistance. Here I will give you capacitance. Capacitance, right? Capacitance is what, right? Capacitance is epsilon naught by d, right? Depends on the plate also. Depends on the distance also. What is the unit of capacitance? Capacitance unit is Faraday. Faraday. Yes. So the capacitance unit is Faraday. Chuskondi. 1 ampere, 1 coulomb, 1 Faraday. Huge numbers. Are you understanding? 1 ampere until it is too much of current. If you touch 1 ampere, you will be gone. Understanding? Similarly, 1 coulomb, huge number. Huge. 1 Faraday, huge number. Are you understanding? The capacitors will not be given to you in 2 farad, 3 farad. They will be in microfarad. Microfarad ante 3 microfarad of capacitance is there. Cheppandi. So if you have 3 micro ante entira? Micro is what? 10 to the power minus 12. Yes. Faraday, microfarad is there. So it is 10 to the power minus 12 kada? Yes. So cheppandi. Sir, these plates will have charges now. What is the formula for charges? Good. Very good. 1 Faraday is equals to 1 coulomb by 1 volt. And 1 Farad is equals to coulomb per volt. Understanding? Very good. Josna Reddy, very good. Next. Okay. So 3 microfarad is the capacitance. See value I gave. I gave the value. So sir, formula for capacitance is Q by V. Circuit lo matladalante Q should be the charges on the plates. Ante kada? Yes. What is V? V is the potential of the battery. V is the potential of the battery. No, no. V is simply the potential difference across the ends of this capacitor. Ardhamingindariki. Re Kesava Narayana, re enough na. Enough, enough. Are you understanding? Enough. Chuskondi. Okay, great. Okay, great. So V is what, right? Potential difference across the ends of the capacitors. So sir, if I assume the potential here to be 0, ekkada 0 assume chesi, here also it comes out to be 0, automatically you are going from negative to positive until it becomes 10. It also becomes 10 kada? Yes. Cheppandi, what is the potential difference across the ends? 10. Good, good. Ippudu cheppandi charge gurinchi. So charge is equals to C into V ante kada? Very important formula. Very important formula. Substitute the values. Substitute. C is 3 microfarad multiplied by V is 20 volt. Oh, so it is coming to be 60 microcoulombs. Understanding? 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 Okay. Nice. Nice, 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 nice. So, ఏమవుతుంది sir? Sir, what is exactly the phenomena re? Are చూసుకోండి re. This is the negative terminal, this is a positive terminal. Ante positive charge is flowing. Do we say positive charge is flowing ra? So, ఏమైతది ra? Negative charge flows from this plate. చూసుకోండి, చూసుకోండి, చూసుకోండి. Negative charge ante electrons are flowing, something like this. So, E plate lo extra electrons are getting deposited kada? Yes. So, slowly, negative charge is getting accumulated. Ra. But if electrons are getting accumulated here, where are they coming from? Where are they coming from? They are coming from this plate. Yes. So, they are coming from this plate. Until the battery is doing only one thing, it is removing the electrons and it is sending to other side. Something like this. Hey, something like this. Something to this. Understanding? So battery is removing electron from one plate and sending it to other plate. If it is like this, then there will be charge imbalance. It will be plus charge, it will be minus charge. I want that only. Then and only then it transforms to a capacitor. Are you understanding, Andarigi? Are you understanding? What no, sir? What no, sir? So, a battery basically takes the charge from one plate and shifts to the other plate. Are you understanding? Takes from here, sends there. Takes from here, sends there. Takes from here. What? What? Electrons. Electrons. Negative charge. Okay? Negative charge. Negative charge. So, there will be a potential difference generated automatically. Endugura? Charge difference is there. Oh, capacitance is also there. So, sir, Q is equals to C into V. Ante kada? Yes. Yes, very good. Hey, who is this? Thank you, Uzumaki Naruto. Thank you so much. Okay, okay, Parimala. Let's move to the next topic. So, let us say, this is my battery of 20 volt. Hey, 20 volt battery. Hey, this is the capacitor. Cheppandi. So if I tell you the initial charge is minus 2 microcoulombs. Ekkada initial charge is plus 2 microcoulombs. Andariki chuskondi. I am asking you one question, okay? If the capacitor C is equals to 4 microfarad, andariki cheppandi. Question is, what or find the charge flown through the wires. Cheppura. What is the charge flown through the wires? Andariki cheppandi. Cheppandi. What is the charge flown through the wires? Wires ante telusa? Wires ante telusa? Yes. 78. 78. Okay, let us see. In the final scenario, the scene should look something like this. Idina battery. This is my capacitor. Ante kada? Yes. 20 volt battery. 4 microfarad capacitor. Okay? Yes. So, Q is equals to C into V. So, Q is equals to C into V. Kada? What is C? C is 4 microfarad. What is V? V is 80 volt. Ante 320. 20 volt. 20 volt. 20 volt. Ante 80 microcoulomb. This should be Q kada. Kani ela distribute cheyalera. This is positive terminal of battery. Ante this plate will have positive charge. How much positive charge? 80 coulomb. Not 8 plus 80 coulomb microcoulomb. And here minus 80 microcoulomb. Chuskondi andariki. Ante kada. But chuskondi. Initially it had minus 2. Finally it had plus 80 . Initially it had minus 2. Finally it had 80 . Cheppandi. Charge flown delta Q is equals to QF minus QI. Ante kada. QF is how much? 80. Minus QI is how much? Minus 2. Ante 82 microcoulomb is the charge flown through the wires. Ardhamaina andariki? You're not understanding, Ray. Hey, you are getting confused, Ray. Oh, sir, what are you doing, sir? We are getting headache, sir. Nice, Sriraj. Good. Chuskondi. Or three capacitors. Three capacitors. Okay. What to do now? Don't worry. It's a very easy part. I'll tell you. Choose Kundi. C1 is equals to 2 microfarad. C2 is equals to 4 microfarad. And C3 is equals to again 6 microfarad. Cheppandi. Ante kada? Yes. So the question asks, what is it asking? Find potential across each capacitor. Voltage. How much should I take? Is it relevant? Is it relevant? It's not relevant for now to discuss. Okay, we'll discuss it later on. Leave this question as it is. Ippudu energy stored in capacitor gurinchi maatladtam andariki ardham cheskondi. Leave your works. Leave your works. So, sir, energy stored in capacitors. Okay. So this is my capacitor. Ante kada, idi na battery. Voltage V. How many of you remember? In lecture ki beginning I have told you something about potential kada. What is potential? Potential is work done per unit charge. Potential difference kada. What can I write? I can simply write work is equals to Q into V. P into what? Potential difference. Potential difference kada? Yes. But if Q is variable, what should I write? Take small q. Ante kada? Yes, take small q. So dW is equals to small q, right? Small q is dq multiplied by potential is V. Great. Understanding? Okay, Darkan, why are you getting distracted, Darkan? Is anyone harassing you or something? Okay. Why, Darkan? Why you are getting distracted, Darkan? Okay. So let us say, initially the plates were neutral, okay? Initially the plates were neutral. Slowly, the battery is sending charge, ra. And let us say Q charge has been accumulated, ra. E plate Y plus Q and దీంట్లో minus Q charge has been accumulated. అంతే కదా? అంతే కదా? అంతే కదా? Okay. So, again the battery is sending the charge, ray. Again the battery is sending the charge. How much? Small charge. dq. Okay. So, small charge is dq. ante kada? Yes. What should you write about the work done? Work done is what? Right? dq into v kada? Okay, sir. V is what, sir? V is what? Q by C. V is what, sir? Q by C kada? Ray. How? What? How, ray? What? How, ray? What? How, ray? So it is dq into v is q by c. Idi ma d work kada? Yes, dw. Arey, small dw's add up, re. For adding we use integration kada? Yes, integrate. Oh, nice. So the total work w is equals to sir, c is constant, sir. 1 by c outside. Integral q q dq. Oh, q dq x dx. Integral x dx ra. Power 1 ఉంటుంది కదా, increase the power. Oh sir, 1 by c into q square by 2 అంటే q square by 2c is the work done. By what? Work done by battery. Work done by battery. Battery is q square by 2c. Same work, it is politely accepting it in itself, ra. The capacitor is slowly accepting the same work and storing inside itself as the energy andarki chudandi. Next, so what can I say, sir? Sir, W is equals to energy stored in the capacitor. So U is equals to Q squared by 2C. Hare, what is Q, re? What is Q? Q is equals to C into V, ra. Are C into V, re, substitute, re. So CV whole square by 2C అంటే C square V square by 2C. CC gone, half CV squared. ఇలా కూడా రాయొచ్చు. You can write the energy in the capacitor in two different ways, రే. Q square by 2C లేదా half CV square. అర్థమైంది? Q square by 2C or half CV squared. Many of them? Good. Kerala Chari, very good. I don't know how many of you are listening very seriously, ra? But energy stored in capacitor is equals to half CV square or U is equals to Q square by 2C. What is Q, right? What is Q? Q is the charge. Q is the charge on the capacitor. To be more specific, I'm not going into much details. Gurtupetukondi. Q is the charge of the positive plate of a capacitor, okay? Positive plate of a capacitor. Q is the charge of positive plate of capacitor. Good. Hey, what is C, right? C is the capacitance. Leda, what is V, right? V is the potential of the battery. Ante kada? Potential of the battery. No. V is potential across potential across the ends of capacitor. Oh, nice, sir, nice. We are understanding everything. Okay, nice. Okay, so ఇప్పుడు let us take a PYQ, ra. Yes. Did I write capacitor, re? Capacitance, re. Hey, capacitance, re. Not capacitor, re. Hey, capacitance, ra. Hey, who is it, re? Hey, C is capacitor, re. Not capacitor. Kerlachari says capacitors. It's not a capacitor. Okay. చూద్దాం క్వశ్చన్ తీసుకోండి. One. Increases. 2. 3. 4. చాలా పెద్ద క్వశ్చన్ రా, మై హ్యాండ్ ఇస్ పెయినింగ్ రే. ఓకే, నో. It's 5. It's 5. Okay, it's 5. It's 5. Okay, it's option number 5. It's not looking like 5, but it is 5. Okay, okay, it's 5. Option A, 1, 2, 3 only. Option B, B is water. B is water. I don't know. I don't know. Take some other options. Okay, okay, 2, 1, 3 only. Option C is 1, 3, 5 only, and option D is all. Chappora, which are correct? Chuskondi. They say that NEET does not ask multiple correct type questions, but it is asking, Ray. It is asking, okay? It is asking. Good. Okay, I'll be back in 1 minute, okay? You try this question, Andariki. Chapora. I'm back. Yeah, I'm back. What is going on, right? Okay. So, sir, plates are brought towards each other and the distance decrease. Distance decrease and Spandana, energy is stored, Spandana. How can you say it's not stored? So capacitance is A into epsilon naught by D ante kada. So D value decrease ayindi, automatically C increase this ra. Ante kada, inversely proportional to distance D. If C is increasing, write whatever formula you know about capacitance. Choose koni. What is it asking re? Energy stored. Energy stored ki formula enti ra? Energy is half C V squared. Right? Yes. Yes. Next. So if capacitance increased, capacitance increased, the energy increased. Yes. Valid. Point number 1, valid. Not. It is talking about charge rate. It's talking about charge rate. Charge rate. So charge ki formula cheppura. So Q is equals to C into V kada. Again, capacitance increased, so charge also increased. 1 also valid. Energy increased kada, not decreased. So it is gone. It is not there. Capacitance increased. Ippudu chusina kada. Capacitance increased. Capacitance increased kada. Yes. So the capacitance is increased. Next ratio of charge to potential remains the same. Charge to potential. Charge to potential ratio ra. Sir, charge to potential ratio re. It is capacitance only re. Capacitance only re. So capacitance increasing kada. So ratio of charge to voltage also increasing. Hi Nandini, hi. So ante this is capacitance. It does not remain same. It increases ra. And product of charge and potential increases. Charge is increasing kada. Yes, it is increasing. So the product also increases. Finished ra. Finished re. 135 are correct re. 135 are correct. Next. Okay. Andariki cheppandi okkasari. How many are watching re? Good. Good. Spark Harsha. Very good. Hi. Hi Spark Harsha. Hi. How are you all? Okay, fine. So let us continue. Let us continue our discussion. Choose kondi. So this is my capacitor kada. Yes, this is your capacitor. Voltage V re and capacitance C re. How much is the charge stored? How much is the charge stored? Cheppandi andariki. Hi Shirisha Reddy. Hi Nandini. Good evening. Okay, so charge guruji cheppora. How much charge is stored re? So the positive terminal and positive charge is stored. Q is equals to CV and ikkada minus CV ante kada. Yes, good. Okay, so let us say capacitance is C1 ra, potential is V. So charge is C1V, C1V, ante kada. Now what I'm doing is, I'm removing this battery. Hare, what are you doing, sir? Sir, you are removing the battery. Hare, yes, I'm removing the battery. Okay, so battery removed. Oh, gone. Epudu what? Charge is there. Yes, it is there. It is there. It will be there. As long as you connect this wire to something else, charge will be same. Andariki ardham cheskondi, gurtupettukondi. Okay. Okay, is this? Okay, so what I'm doing is I'm connecting this with another capacitor having capacitance equals to C2. The charge will flow. Charge will flow, kada? Yes. So from positive plate to negative plate, the charge will flow. How much charge flows? How much charge flows? How much charge flows? So it will flow such that the potential difference across each capacitor is the same. Why? Because they are connected with the same wire kada. Chuskondi wire. These 2 points also connected by wire. So 2 points connected by wire have same potential difference. Ante kada. Yes. So the potential difference between the wires is same. Ante wires do not change the potential difference. So that means the potential difference across the ends of this capacitor is equals to this capacitor. Ante kada? So let us say okay, let us say X charge is gone, X charge is gone. So final scenario lo situation looks something like this. So idi me rendu capacitors and it is C minus X. Okay, so it is X-ray. Yes. Charge gone kada. It is received by this plate. So if it is a plus X, it will be minus X. Andariki ardham cheskondi. If it is minus X, then here the charge will be added plus X. So it is minus CV plus X. This figure is very important. Understanding. Okay. So sir, cheppandi sir, capacitor C1, C1V and capacitor C2 ante kada. So voltage should be same, voltage across should be same. Q is equals to C into V. Sir, V is equals to Q by C. Ante Q1 by C1 should be equals to Q2 by C2. Ante kada? Yes. Q1 value entira X by C is C2 should be equals to C1V minus X by C1. Ekkad nunchi you can easily find out the value of X ra. How much charge is flowed? Cross multiply cheskondi. Cheppandi. So C1 into X is equals to C2 C1V minus C2 into X. Ante kada? You send this C2X this side. Chappo C1X plus C2X is equals to C1 C2V. Ekkad nunchi? Hare X ni common teesavara. X ni common teesko. So sir, C1 plus C2 into X is equals to C1 C2V. Oh. So sir, X is equals to C1 C2V divided by C1 plus C2. Nice. So this is the amount of charge that flows. Choose kondi. Initially I had a battery. A battery lo I connected a capacitor. Dan tarvata okasari capacitor charge I am removing the battery. Remove chesi I am attaching one more capacitor C2. So emaitadi ante the charge is flowing from the charged capacitor to uncharged capacitor. Enta charge flowing is sir? Sir, it is equals to C1 C2V by C1 plus C2. Good. Spark Harsha, very good. So this is the amount of charge that is flown. Andariki ardham cheskondi, it has been asked in the PYQs. Recent time PYQs. Okay, so let us say question from PYQ. A capacitor of capacitance 900 picofarad. Okay, C is equals to 900. P is for pico, not sari fall pico, it's pico. 10 to the power minus 15. Minus 15, okay? Minus 15. Good. Good. Picofarad is charged by a battery. Then it is disconnected from the battery. Chuskondi, same thing, Ray. Same thing, okay, as I told you earlier. And connected to another uncharged capacitor. Same capacitance, okay, again, Malli capacitance 900 microfarad as shown in figure B. Or figure B, figure B. Figure A, figure A, okay, figure A. I will tell you options also, okay. Option A, nice. Okay. Okay, Nandini, got it. Noted, noted. C1 V1 plus C2 V2 by C1 plus C2. Spandana. What are you talking about? You're talking about the potential difference. Hey. CV squared. CV squared. Okay. D. చెప్పండి అందరికి. So it's a good question actually. Okay, good question. Yes, not 12. Joshna, pico ante -15. Okay, micro ante 10 to the power -12. Nano ante -9. Are micro ante -6 re. Yes, pico ante -12. Pico ante -12. -6 is for micro re. Did I write -6 only re? Did I write -6 only re? I think I read somewhere micro was there. Micro was there. I don't know. Where was it? Did I write only -6? Micro for -6, okay, and pico for -12. Pico for -12, micro for -6. Micro for -6. Choose according to it to adjust it. Okay, according to that you adjust it. Next. చూద్దాం రా, చూసుకోండి అందరికి. సో దిస్ ఇస్ మై కెపాసిటర్ కనెక్టెడ్ టు 100 volt బ్యాటరీ. 100 volt బ్యాటరీ ఇస్ దేర్. వాట్ ఈస్ ద కెపాసిటర్ వాల్యూ? 900 picofarad కదా. ఎస్. సో C is equals to 900 picofarad. Then this capacitor is removed and connected to another capacitor. CC same ra. Cheppandi, what is the value of charge re? Q is equals to C into V kada. Yes, C into V is the charge. Ante it will have plus CV, it will have minus CV. As soon as I connect it to another capacitor, the charge gets half. Ante kada. How half re? How half? Remember the formula re. So now becomes half CV. Here also half CV is equals to charge. Ante kada? Ante kada? Yes. Chuskoni andariki. Cheppandi. So sir, if it is Q, it is Q by 2. Idi kuda Q by 2. Ante kada? Yes. Now total energy ra. Cheppandi. What is the total energy? Q square by 2C kada plus Q square by 2C. In both the capacitors re. So Q value is Q by 2 re. Q by 2 whole square by 2C plus Q by 2 whole square by 2C. Ante kada? So it becomes, cheppandi, 2 into Q by 2 whole square by 2C, 2 gone. That is 1 by 4 into Q square by C. What is Q re? What is Q? Q is half CV. Half CV. Ante kada? Half CV. Half CV, not half CV re. CV re. CV. Finished. Substitute cheskondi values. So 1 by 4 into C value is how much, Sarji? 900 into V square is 100 square. Can it is a picofarad, so 10 to the power minus 12. Right? Yeah, Spandana, you're telling something. Chattunnaru. Okay, sir. So 1 by 4 into 9 into 10 to the power 6 into 10 to the power minus 12. Ante kada? So that comes out to be 9 by 4 into 10 to the power minus 6. 9 by 4 ante enti ra? 2.25 10 to the power minus 6. 2.25 re. Where is it? Hey, D. Ante kada? Good. Next. Any more PYQs? Yes, there is a PYQ actually. Doubled and the area is halved. Full stop. If C is initial capacitance, I took this question, okay, earlier also, but there was not the tag of NEET for this. If C is initial capacitance, final capacitance is what? చెప్పండి అందరికి. Good. Joshna, very good. Very good. Very good. Very good. Very good. Okay. So, sir, initially, a distance D and area A kada. So, sir, capacitance initial is equals to A epsilon naught by D. Eppudu em chesadu sir? Now you are doubling the distance and reducing the area by half. So, ante C2 is equals to area by 2 into epsilon naught by 2 into D kada. So it is equals to A epsilon naught by 4D ante 1 by 4 into A epsilon naught by D. Array, this is only initial value re. So 1 by 4 into C ante option A. Good. Hey, edits. Why do you want to know where I am from? Endugura? Endugu? I'm from somewhere. Okay. Now, one last question from BYUs and then we'll be moving to the next topic, right? Are you understanding what I'm telling you? Do you understand this language or am I just wasting your time by talking in such a tone, ra? A capacitor of capacitance C1 charged up to V volt. Charged up to V volts. Then connected to uncharged capacitor C2. Then connected full stop. Hey, why am I writing these questions, Ray? I can do typed also. But when I'm typing the questions is already available on your slides. What you're doing is, some question is there, some answer is there. Let that be. I'm not going to do anything. At least I'm writing. So in that time, even 1% of you could, understand what I'm writing, at least read. Then you might get the feeling or little urge to Array Shiva, I do have to keep energy levels high, Ray. Okay, so there are different types of students in the classroom. They are from different levels, different mental states, different understandings, different intelligences. Okay, so I have to take each and everyone with me and I have to keep this track. That is the reason why I'm on. Okay. The final potential difference across. dash. So this was asked a very old question, Ray. A very old question, Ray. 2002 kada. Option A. Teeskondi. C1V by C1 plus C2. Option B. 1 minus C2 by C1 into V. Option C. C2V by C1 plus C2. And option D, chappo. I don't know, what is it? 1 plus C2 by C1 into V. Very good question actually, okay? Again, it's a very good question. Who is it? Who is it? So, what is the answer, Ray? Choose chalo. Let us try to find the answer for this. So, initially capacitance C1 kada? Yes, connected to V volt. So, idina battery, and this is the capacitance of C1. Ante kada? Yes. Now, what I am doing is, I am trying to calculate the charge. Chappandi. What is the charge? Q is equals to CV kada? Yes. So let us say voltage is V ra. Andarki chuskondi. So sir, C1 into V plus ekkada minus C1 into V. Ante kada? Very good. Very good. Now what I am doing is, I am removing this battery ra. So let us slowly remove this battery. Ante. Good. So remove chesi. I am going to attach one more capacitance over here ra. What is the value? C2. C2. Good. So sir, C2 is the value. What will happen now? Some charge will flow from C1 to C2. Ante kada? Why? Why is it flowing? Because we have to keep the potential difference same. So let us say some X charge is flowing from this plate. The charge on this plate becomes X. On this plate becomes minus X. If it is minus X, it will be plus X here also. What will be the value of X? What will be the value of X? Choose kondi. I have directly calculated that, right? Where did I calculate it? Here. So this is the value of X. Ante kada? If you are remembering, directly I am writing it, okay? Good. I am directly writing it. C1 C2 V by C1 plus C2. Okay. So sir, X is equals to C1 C2 V divided by C1 plus C2. Ante kada? Yes. Now come at this capacitor. This only, only focus on this one. Only focus on this capacitor. Choose kondi. If the capacitor is C2, ante kada? If the charge across the plates of the capacitor, Q is equals to C1 C2V divided by C1 plus C2. Ante kada. Q is what? Right? C into V. C into V. C into V. What is C? C is C2 into V dash. Ante kada. So this C2 gone. Right? You're only left with V dash is equals to C1V by C1 plus C2. So that remains the potential on the across the ends of the capacitor. Ante kada? Hey, what are you commenting? Right? Okay. Chalo, good. So let us talk about combinations of capacitors. Next topic. Immediate next topic, sir. Combination of capacitors. Right? Right. Good. Not current. In your class 10th, you had combinations of resistors, kada? Yes. So you had combinations of resistors. Very good. Parimala, very good actually. Good, good, good. So you had combinations of resistors. What did we write over there? So let us say this value is R1 and here the value is R2. So sir, if there is series, you can say net resistor is equals to R1 plus R2. Ante kada? Yes. Good. Good. What if they are in parallel? What if they are in parallel? Cheppandi andariki. So if the resistors are in parallel, this is R1, idena R2. What should I write? 1 by R1 is equals to 1 by R net is equals to 1 by R1 plus 1 by R2 kada? Yes. So 1 by R net is equals to 1 by R1 plus 1 by R2. I'm just telling you to revise it, okay? Compare it. We are going to compare it with the capacitors in the end. Understanding, very good. Very good. Spandana, very good. Very good. Next. So let us talk about series combination of capacitor. Choose kora. Series combination of capacitor ante, if I have two capacitors and I plug them in series, and if this is my first capacitor, choose kondi C1, and this is my second capacitor C2. It is C1, it is C2. Ante kada? And if I'm connecting them with voltage, so let us connect them with voltage also. So let us say this is my voltage V. Sir, initially the capacitors were neutral. Now what's happening? This battery, this idiot fellow battery, it is removing some electrons, not electrons, positive charge. Okay, so removing electrons from this side. Yes. So this idiot, it is removing some electrons from this side and all the way sending it to that plate. Oh my God. So that battery is removing the electrons and sending it to other plate. Yes. Yes. So let us say if the electrons are coming from this side, I'm telling you again and again. If this battery is removing the electrons from this plate, what's happening? What's happening? So sir, there will be positive charge on this plate. Electrons are gone, kada? Yes. And there will be negative charge on this plate. So yeah, good, very good. But let us say voltage is V, kada? Voltage is V, voltage is V. So let us say Q is the charge plus Q on this battery. So on this battery there will be minus Q charge. Ante kada? Yes. Ardham cheskondi andariki. It will be minus Q, So if it is plus Q, it is minus Q. So what happens now? If this is negative Q charge, automatically the positive charge of this neutral plate will get attracted to the negative charge, this one. So it becomes plus Q automatically. And if it is plus Q, the electrons ran into that part, it becomes minus Q. Ante kada? Point number 1 to be noted, my lord. Point number 1 to be noted, my lord. Whenever the capacitors are connected in series, the charge across each is same. అర్థం చేసుకోండి. Whenever the capacitors are connected in series, the charge across each capacitor is the same. Plus Q minus Q. Plus Q minus Q. Ante kada? Yes. So, what will you do now, Ray? What is going on in the chat? I'm not understanding at all, Ray. Ray, చూసుకోండి, chalo. So now, what will I say? Let us say it is 0. Let us say it is V. It is V. It is 0. It is X. Ante kada? So the potential difference across this capacitor, it is V2. And the potential difference across this capacitor, it is V1. Ante kada? Yes. Yes. So the potential differences are V1 and V2, ra. So if I have to replace this whole system with another capacitance, చూసుకోండి. So ఇది the net capacitor. అందరికీ అర్థం చేసుకోండి. C net అంటే V net కదా. So what should I write? Net potential difference across this capacitor, V net. Simply V net is equals to V1 plus V2. అంతే కదా. But sir, Q is equals to C into V. V is equals to Q by C. Ante kada? Yes. V is equals to Q by C. So Vn is equals to Q by Cn is equals to Q by C1 plus Q by C2. Ante kada? Q gone. So what I can say? 1 by C net is equals to 1 by C1 plus 1 by C2. Finished. So if the capacitors are in series, they get added up as resistance in parallel. Are you understanding? Are you understanding? Are you understanding? Okay, okay, good. Good, very good. Spandana, very good. Very good. Next. What about parallel? Parallel gurinchi cheppandi andariki. So if the capacitances are in parallel, ante this is my first capacitor C1, edi na second capacitor C2. Ante kada? So what we are doing now, sir, we are replacing this with another capacitor. So this is my net capacitor Cn. Ante kada? So what will happen? Cheppandi andariki. What will happen? So I can simply say potential difference across each capacitor is the same. Right? Why? Because it's a wire. And wire has same potential difference. Understanding? So sir, here V is equals to same ra. చూసుకోండి. V is equals to V. అంటే చెప్పండి, if charge Q1 is accumulated on first capacitor, రెండు capacitorలో Q2 is accumulated, and here charge Q net is accumulated, what can I say? Oh, I can simply say, sir, Q net is equals to Q1 plus Q2. Q net అంటే ఏంటి sir? C net into V. Potential is same. Potential is same across both the capacitors. So is equals to C1 into V plus C2 into V. Ante kada? V gone. So you can simply say C net is equals to C1 plus C2. Good. Very good. Spandana, very good. Very good. Very good. Josna Reddy, very good. Chalo. Good, good, good. So if the capacitors are in series, andariki chuskondi. C1, C2, C3. 1 by C net is equals to 1 by C1 plus 1 by C2 plus 1 by C3 plus finished. If they are in parallel, if the capacitances are in parallel, so this is my first capacitor, idi na second one, idi na third one, and so on and so forth. Okay. Something like this. They are going in parallel. C1, C2, C3. What can I write? C net is equals to C1 plus C2 plus C3 plus C4 and so on and so forth. Question from the last PYQs. Okay, let's take direct PYQs. No time waste. Okay. What are you telling me? Chalo. So let us see about the questions now. చెప్పండి అందరికి. So this is the question. ఇది నా పాయింట్ బి, ఇది నా పాయింట్ ఏ రే. ఏ రే 3 microfarad. ఇక్కడ కూడా 3 microfarad. Here also 3 microfarad. Options తీసుకోండి. I don't know the options. కానీ ఆప్షన్ ఏ రా 3 microfarad. ఆప్షన్ బి రా 2 microfarad. ఆప్షన్ సి రా 1 microfarad. and ఆప్షన్ డి రా అరే none. Not none. None. Do they give you none? They don't give you none. Okay. So let us say 4 microfarad. Chapandi. Yeah. Okay. So the break will be at 8 p.m. Good. Not 3 ray. It's not 3 ray. It is not 3. Andariki చూసుకోండి. Initially, these two are in parallel. So if the capacitors are in parallel, they add up like resistance is series. అంతే కదా? So 3 and 3 are in parallel అంటే they are simply getting added up. C net is equals to C1 plus C2 అంతే కదా? అంటే 3 plus 3 is 6 microfarad. So ఇక్కడ నుంచి you have a capacitor of 3 microfarad and this is 6 microfarad. చెప్పండి. They are in series. Series లో ఉంటే you can simply say చెప్పండి 1 by C net is equals to 1 by C1 plus 1 by C2 or directly remember the formula it is equals to C1 C2 by C1 plus C2 చెప్పండి. So 3 into 6 divided by 3 plus 6 kada. So it is 18 by 9 అంటే 2 microfarad. 2 is here. Done. Finished. Okay. Next. Question. It has been asked multiple times, okay, at least this question, at least on this. So I hope and I expect all of you to do this part only. Choose Kondi. There's no meaning at all, right? There's no meaning at all, right? Chap. So options I don't know, right? Okay, so let us see for the options. Hopefully they are available. Okay, yes, they are there. So option A, it is 3C. Option B, it is 3C by 2, ra. So it is 3C by 2. Option C, it is 2C. And option D, it is C by 2. చెప్పండి అందరికి. Getting it? Not getting it? No. Josna, no. Good. Good. Spandana, very good. Good. Spandana, good. Yes. Chuddam ra. You understand, Re? It is wire, Re. It is simple wire, Re. Wire ante enti ra? Every point on the wire is at the same potential. Ante kada. So ante these 2 points, చూసుకోండి. This point and this point, they are at the same potential, ra. So if the potential is the same, ante no current is flowing. There is no charge is flowing. So that means this capacitor is of no use, ra. This capacitor is of no use. It is connected with a wire. Understanding? Understanding? So 2 capacitors in parallel, ra. So C plus C. Okay. 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 So net capacitance C net is equals to C plus C and 2C. Next. Next to the next. Okay. Equivalent capacitance of the arrangement. Same question, ra. Capacitance. ఇది కూడా capacitance. ఇది కూడా capacitance. This is also capacitance. అందరికీ అర్థం చేసుకోండి. And then this is a battery. Positive, negative terminal. This is E. 15 microfarad. ఇది కూడా 15 microfarad. 15 microfarad. Good. And this is also 15 microfarad. Option A. This is asked in NEET 2023. Option A is 10 microfarad. Option B is 20 microfarad. Option C is 30 microfarad. And option D is 40 microfarad. Ante kada? Cheppandi. Good. Good. Spandana, Parimala, very good. చూసుకోండి. అరే these are in series, రే. చూసుకో. All 3 are in series kada. They are in series, రే. They are in series. And one more thing, you remember as a shortcut, okay? Shortcut. If n capacitors are in series, చూసుకోండి. If this is in series, this is in series, this is in series, this is in series, this is in series. How much? 1, 2, 3, 4, 5, 6. Kada? If all are same, if all are same, then you can directly write is equals to C by 6 until. Finished. Understanding? Understanding? Same thing. Tell me, the 3 are in series. So 15, 15, 15. What should I write? 15 by 3 kada? 5, 5, 5. So instead of all these 3 capacitors, should I write something here? Okay, Chapandi. So instead of all 3, I am only replacing with 5 microfarad and connected to it is 15 microfarad. Ra. Okay, immediately a battery is there. Choose kondi 50 micro. Cheppora net capacitance C net is equals to C1 C2 by C1 plus C2. Ante kada values cheppandi 5 into 15 divided by 20. Are we doing some mistakes? Are we doing some mistakes? Are we doing some mistakes? 15 into 5, 5 into 15 kada? 5 and 50 are in parallel. If they are in parallel, you cannot use this formula. If they are in parallel, C1 plus C2 ante. So C1 value is 5, C2 is 15 and 20 microfarad. This is my net capacitance. Ardhamaindi kada? Good. Next chuddam re. I think I should take few more questions and then stop re. Okay. Sufficient. Enough. So I don't find any PYQs now. So let us continue with our theory, okay? Let us continue with our discussion. Andariki. Choose code. It's gone. Okay. Sir. CM circuit theory as your current electricity. Wheatstone bridge telusa. Wheatstone bridge telusa. If you don't know, I'll tell you now, okay? Choose kondi. You will also encounter the same Wheatstone bridge in your current electricity chapter also. Understanding. Andariki array. Point A, this is point B. Ante kada? If C1, C2, C3, C4. Choose kondi andar yere, it's a Wheatstone bridge. If C1 by C2 is equals to C3 by C4, C4, then remove the middle capacitor. Ante kada? So the situation will look something like this. Final situation, look, you have I hope it's visible to all of you, okay? So now you can take them as series and parallel. Yes. So sir, these are our capacitors C1 and then C3. Ante kada? Yes. So this is C2. Ekkadochi, a capacitor is C4. And then finish. Now you can directly do it. Okay. Let's see a question. Question that was asked in NEET. NEET? Which year? Which year was the question asked today? Okay, 2024 ra. చెప్పండి అందరికి. ఆప్షన్ ఏ 1 microfarad, ఆప్షన్ బి 2 microfarad, ఆప్షన్ సి 0.5 microfarad, వేరే 0.5 microfarad. ఎవరే 0.5 microfarad and option D. Should I write it? Okay. 4 microfarad. Yeah. It is a Wheatstone bridge, right? It is. ఎందుకు సార్? రేషియో చూడండి. రేషియో గురించి మాట్లాడితే C1/C2 is what రే? Sir, C1/C2 is 2/2 is equals to 1 is equals to C3/C4. అంతే కదా? C3/C4 చూసుకోండి. If it is a balanced Wheatstone bridge, దానికి మనం ఏం చేస్తామంటే you simply cut this middle capacitor. అంటే the figure will look something like this now రా. చూసుకోండి. పాయింట్ ఏ పాయింట్ బి. అరే చెప్పురా, తొందరగా చెప్పు. 2 2 2 2 అంతే కదా? 2 2 సిరీస్ 1 2 2 సిరీస్ 1 అంటే this is 1 this is 1. చెప్పండి. 1 + 1 in parallel అంటే C0 is equals to 1 + 1 is equals to 2 microfarad. అరే I'm writing but you should also understand na. If not you, at least the students who will be watching after you, they should understand రే. అంతే కదా? గుడ్. Okay, anything more left? I think everything is done. Okay, right, circuit theory has been completed. Now we'll talk about dielectrics. We will talk about dielectrics రా. చూసుకోండి. Good. What is a dielectric? Sir, what is a dielectric? Or else should we take a break, Ray? Break for 15 minutes. Okay, okay. All good, all well. Okay. Hey, Parimala, what are you asking, Parimala? Why do you need phone number? Okay, so let us start. Hi. Hello, Spandana. Hi, Kanmani. Hi. So, let us start the most interesting topic in capacitors. Okay. Array, dielectric గురించి discuss చేసే ముందు I want to tell you about something, okay? So let us imagine a situation రా. ఒక situation imagine చేద్దాం. You imagine you have a metallic cube, okay? You imagine you have a metallic cube. అంతే కదా? It's a metallic cube రా, అందరికీ చూసుకోండి. So if it is a metallic cube, let us say I am placing a plus q charge right side of this cube. Got it? Understanding? Good. Very good. How many Narutos are there? Okay. So ఏమైతదిరా? So sir, if you are bringing a positive charge, అంటే రజనీకాంత్ వచ్చింది సార్. So all these old women, once upon a time, the woman has the huge crush on Rajnikant, but now all became older. So all those old women, they are running away to see him. Okay, all the women came in the right side to see Rajnikant. Negative charge. All the negative charge accumulated or attracted towards this positive charge. Ante kada? What about positive charge, re? What about positive charge? Don't you think this positive charge will go here, ra? Chuskondi andariki. So don't you think the positive charge will go here, re? Ere, cheppandi andariki, cheppandi. Are you understanding? Good. So sir, here, ra. So when you observe electric field due to this positive charge, re, how does it go? Electric field due to hi. Tama. Alikya, hi. So, due to this positive charge plus Q, the electric field is away from the charge kada in all sides, but I'm not writing all the sides. You imagine, okay? So, due to this plus Q charge, the field is away from this charge. Ante kada? Good. Very good. So, sir, what about the field inside? Hey, చూసుకోండి. టర్మినాలజీ గురించి చెప్తున్నాను. చూసుకోండి అందరికి. Bye, nice to meet you. Okay. So, because I took this plus q charge, అందరికి చూసుకోండి. Because I took plus q charge, this extra charges got induced kada. So these are the induced charges. Sir, what will be the value of these charges? Same, ditto same ra. So if you are talking about this negative charge, it will be minus q only. And if you are talking about this plus q charge, it will again be plus q. Ante kada? Try to visualize, okay? If it is a conductor, andariki ardham cheskondi. Conductor unte, conductor lo there are huge number of free electrons, right? So the electrons will arrange themselves in such a way that the total amount of charge gets balanced. Ante kada? Now, I'm interested to talk about the electric field inside point of a conductor. Cheppandi. So sir, electric field inside the conductor is because of two different reasons. The first reason is this plus q charge. Plus q charge wala the electric field inside the conductor is in the left side, ante kada. So this is electric field due to plus q charge. Andariki ardham cheskondi. Okay, now when I put this plus q charge, these charges got induced. ఇప్పుడు చూడండి, only between these two charges, only within these two charges, tell me the electric field. Sir, electric field is directed away from positive and towards this negative. అంటే this is the induced electric field. అందరికీ అర్థమైంది కదా? So if it is a conductor, the induced electric field E induced must be equals to the external electric field E external. And if the two are equal, ante the net field will be zero. Ante kada? Yes. So E net is equals to E induced minus, you can write something like this. So E external minus E induced. Ante kada? So it is zero. Always remember, electric field inside a conductor is always zero. Are slow ga cheptunnanu, lil moon. I'm telling you slow only. So if you talk about the net field inside the conductor, it is always zero. Why? Because hey, you try to understand it, okay? Because the conductor has a lot of free electrons. Andariki ardham cheskondi, conductor has a lot of free electrons. It can send those free electrons wherever it wants. So how will it send, Ray? It will send in such a way that the net field inside the conductor is always zero. Ante kada? Good. So now let us talk about dielectric ray. What is dielectric ray? Sir, dielectric is a special type of material. Dielectric is a special type of material that does not have huge number of free electrons. Ante dielectric lo free electrons are limited. Ardhamaindi kada? So in the dielectric, the free electrons, they are limited. That means, sir, if this is my parallel plate capacitor, andariki ardham cheskondi. If this is my parallel plate capacitor, sir, let us say E plate pai there is a positive charge plus Q, andariki, and E plate lo there is a negative charge minus Q, ante kada? So if this is the assembly, it has two problems, Ray. It has two problems. The first problem is that one plate is positive charge, second plate is negative charge. When the two plates are very close, they will attract one another. Ante kada? And so if they are attracting one another, there is a huge possibility of a spark. Understanding? And the second biggest possibility is that we have to see if we can increase the capacitance of this system. Are you understanding? Why do we have to increase the capacitance rate? Capacitance increase IE, you can simply say that it can hold more charge now. Ante it can have more energy. Ante it can it can hold more energy. Hold more energy ante it can supply more energy. Ante kada? So it will be a better capacitor in terms of energy also. So my major focus now is to check, is there any other way in which I can stop the plates from attraction? Point number one. Point number two, the second point is I have to check if I can increase the capacitance of this system. Ante kada? So initially we will be talking about the force of attraction between the plates. Endukante it has been asked in your NEET examination. So force of attraction gurinchi maatladite చూసుకోండి అందరికి. So if it is a plus q charge, all of you, and it's a single plate kada, it's a single plate. So electric field guruji cheppandi, electric field is away ante the field value E is equals to sigma by 2 epsilon naught ante kada. So this is a electric field value due to a single sheet having a charge density sigma. Ippudu sir, if another charge, let us say it is electric field E ra, E is the electric field re, Q is the another charge placed inside the electric field. Cheppandi, what is the force? Force is equals to Q into E ante kada. So Q is this charge Q into electric field cheppandi ra. So for this plate, the other plate is exerting field kada. So charge multiplied by field. Field is sigma by 2 epsilon naught ante. So you can simply say Q into, what is sigma? Sigma is the linear charge density of the plate. Not linear, aerial charge density of the plate. And it is Q by area divided by 2 epsilon naught and Q square divided by 2A epsilon naught. This is the force of attraction between the two plates of the capacitors. Gurtupettukondi, if you are understanding this formula, well and good. If you are not understanding this formula, just keep it in your mind. Ante kada? Good, good, good. So the electrostatic force of attraction between the plates of the capacitor is Q square by 2A epsilon naught. Next, sir, we will introduce the dielectric. Cheppandi. So introduction of dielectrics. So dielectric is the material andarki chuskondi. So if these are the two plates connected with a battery, I'm not drawing battery here, okay? So what I'm doing now is I'm going to insert a dielectric into this capacitor. Andarki ardham cheskondi. Jagrataga vinandi, okay? Okay, sir. We understood your language, sir. We'll be focusing at our best level. Let us see what happens now. What will you try, Maitri? What is the discussion going on in the chat? Okay. Chuskondi. So each and every dielectric has some dielectric constant. What is dielectric constant, sir? The dielectric constant is a property of the dielectric material. We'll talk about it later. Kani, you can just imagine that this is a dielectric. Dielectric ante entira. Dielectric ante it is a material whose conductivity is in the range of conductor to non-conductor. Are you understanding? Insulator and conductor. You can simply say dielectric has limited number of electrons. Dielectric has limited number of electrons. Yeah, Joshna, cheppu. What is the doubt? You're asking me or you're asking to the... Okay, tell me, Joshna, what is the doubt? What is going on? Hadar Basha, what is going on? Cheppu. Joshna, are you saying something? Joshna, is there any doubt? No doubt. Here. Chalo, no doubt, then we can continue, okay? So what's happening is, let us say I'm connecting this dielectric with a battery. Andarki chuskondi. I'll draw this time. Like this. So let us assume I'm connecting this with a battery. Something like this. Ardham cheskondi andariki. Yeah. For induced charge, Cheppo. What is the formula for induced charge? Joseph, if it's a conductor, then the induced charge will be equal to the external charge. If it is a conductor, it has free electrons. It has massive number of electrons. So if it is a conductor at all, if at all it is a conductor, Chusko. If at all it is a conductor, then you can simply say external charge is plus Q, induced charge is minus Q. Here, induced charge is plus Q. Ante. If it's a not conductor, if it's a dielectric, then we'll see. That's what I'm telling to you, okay? Charge formula. That's what I'm telling to you. Chusko. So, this is the scenario in which I have a battery of voltage V let us say the two plates of the capacitor, initially the capacitance was C. Andariki ardham cheskondi. The initial capacitance of the system was C initially. Okay. So what? So initial capacitance is C kada? Yes. So if the initial capacitance is C and there will be a charge, Q is equals to C into V. Chuskondi. So here plus C into V will be there, and on this plate the charge will be minus C into V. Ante kada? Yes. So ippudu emaitadi, now that you have placed this dielectric between the two capacitors ra, andariki ardham cheskondi, some charge, let us say Q, minus Q gets accumulated on this plate ra. E plate lo, E face, not plates, you imagine as a cube ra. So cube has face, right? So on this face there is this minus Q charge accumulated. E face lo, there is plus Q charge accumulated. Ante kada? Are you understanding? Yes. So the electric field due to the plates of the capacitor, andariki cheppandi, electric field due to the plates of the capacitor, it is a positive charge, it is negative charge. So field flows from positive to negative kada. So this is my external electric field, E external. Andariki chuskondi. This is my external electric field, E external. At the same time, there will be an induced electric field inside the dielectric. See, this is positive phase of the dielectric, negative phase of the dielectric. The field will be something like this. We call it E induced. Ante kada? Yes. So you take any point on the dielectric ra. Internal point of the dielectric TC, you calculate the net electric field. Cheppandi. So net electric field calculate cheyadaniki, you have to observe the external electric field, E external. Okay. Minus induced electric field, E induced. Ante kada? Are you able to understand? Yes. So what should I say now is, I can simply say net electric field at any point of this dielectric internal point is given as E external, andariki chuskondi, minus E induced. Ante kada? Are you understanding? So sir, if it is minus Q induced, can I simply say it is sigma induced will be the charge density ra, and here it will be plus sigma induced. Are you able to understand? So electric field ki formula cheppura, sigma by epsilon naught minus sigma induced divided by epsilon naught. Ante kada? So what we write it is equals to sigma divided by K into epsilon naught, because the field has been reduced kada. It has been reduced. So 6 minus 2 is 4. Are you understanding? That is 2 by 3 times of 6. I hope you're understanding, right? Okay. So what you write net field, right? E net is equals to sigma by K epsilon naught. We just represent it, right? We just say that this field is sigma by K epsilon naught. Ante this field is E by K. I hope you are able to understand till this point, right? Okay. Dielectric add chesi, the electric field is decreasing, ra. Are you able to understand why it is decreasing? Because dielectric itself is inducing some charge. Due to that charge, some electric field is also getting induced, and that electric field is reducing the external electric field. I hope you are understanding this much. Okay. So ippudu cheppandi, if this is the net electric field, what is the net electric field? Sigma by K into epsilon naught. This is my net electric field. What will you call net potential? Vn is equals to simply E into D. Ante kada? So that means sigma D by K epsilon naught is my potential. Ippudu cheppandi ra. Capacitance is Q by V kada? Charge per potential. So net new capacitance is equals to Q by V. What is Q, right? Q is sigma into area divided by, what is V, right? It is sigma into D by K into epsilon naught. Ante kada? So sigma gone. You take it up. C net is equals to K A epsilon naught by D. So that means sigma new is equals to K into old capacitance. Okay, chuskondira. New capacitance is equals to K into old capacitance. Ante kada? K is usually greater than 1. Until the capacitance now has increased. Chuskondi. The capacitance is increased. Point number 1. And point number 2, this dielectric prevents the plates from sticking one another. Are you understanding? So it's a very beneficial deal for us to introduce this dielectric into the capacitor. అర్థమైంది అందరికీ? So if you are introducing a dielectric, the capacitance increases by k times, where k is simply the dielectric constant of the material. అర్థమైంది అందరికీ? I hope it's visible to you. Okay, next చూసుకోండి. So if you have a capacitor having capacitance C, introduce చేసుకోండి. If you are adding a dielectric అంటే it is shown something like this, ra. Dielectric constant is K now. So the net capacitance now becomes K into C. అంతే కదా? Net capacitance now becomes K into C. అంటే the capacitance has increased. If the capacitance has increased, the capacity to store the charge has increased. అంటే now it can store more charge. అంటే now it can deliver more energy. Are you understanding? So that means okay, so that means it's a very good thing for us. Are you understanding? It's a very good thing for us. Okay, good. So now we will talk about the dielectric constant. Okay. Before that, you remember some properties, okay? Due to introduction of dielectric, the electric field between the plates of capacitor inside dielectric, okay? Inside dielectric, inside dielectric. The electric field between the plates of capacitor, that is inside dielectric, reduces. అంటే new electric field is equals to old electric field by K. అంతే. Finished. అందరికీ అర్థం చేసుకోండి. And then దాని తర్వాత let us go with a question. How did dielectric come? Here also. Not like this. చేసుకోండి. Okay, so let us take a PYQ now. Question is, two thin dielectric slabs K1 and K2 bracket lo తీసుకోండి. K1 is less than K2 are inserted between So this is my capacitor plates. This is my first dielectric. Idi na second dielectric. Chuskondi. So the constant is K1, ikkada the constant is K2. They are not stick to the plate, okay? They are actually at some distances from the plates. And there is also some distance between the dielectrics also, okay? So you have to write about the fields. Option A, chuskondi, graphs gurunchi. Okay, the option A is something like this. Up, down, up, down, up, down. This. Okay, option A. Option B gurunchi cheppandi. So option B is something like this. So this is up, down, up. Not like this, right? Okay, so let us wipe out something like this. Okay, okay. Up, down, up. Option C, da. And option D, చూసుకోండి. Tell me. It's taking too much time to write the questions on board, you know. From?
9. Oh, related link.
Yeah. Okay. So what we get now is, చూసుకోండి, electric field inside the dielectric can be given as E upon K kada. So it is decreasing rate. So when it is in the dielectric, the electric field is decreasing kada. చూసుకోండి. So starting from plate P ray, this is plate Q. Start from this point. Electric field is good. As soon as you come into it, the electric field will decrease. చూసుకోండి. It is good. As soon as you're coming into it, the electric field is decreasing. And then again you are coming out of this dielectric ray. So when you come out of this dielectric, electric field will again increase. చూసుకోండి. Again increasing. And when again you come into dielectric K2, the electric field is again decreasing. అంతే కదా? And again you are coming out of this dielectric, the electric field is again increasing. No doubt to see at all, option A is the right answer. Okay. Next. Okay, next. So we'll end this lecture by 9 ray, okay, because there are some things to be done. So next question తీసుకోండి. చెప్పండి. So this you can simply say, I should say something like this. Okay, so dielectric is added, okay. Array, this is the dielectric. Andarki చూసుకోండి. So this is my first dielectric. Dielectric constant is K1. ఇక్కడ వచ్చి this is my second dielectric ra. So the dielectric constant is K2. Okay, and then you're talking about the third dielectric. The dielectric constant is K3. Andarki cheppandi K3. But let us say the thickness is same for all three of them. It is d by 3. Idi kuda d by 3. Idi kuda d by 3. Cheppandi. So this is my first dielectric, second dielectric, third dielectric. Cheppandi. Can I simply say that all three dielectrics are in series ray? Anyone listening to me? Anyone listening to me? So I can simply say that all three dielectrics, ante you can treat these dielectrics as separate capacitors. You can treat these dielectrics as separate the capacitors. Cheppandi. Then what can you say if the area of the plate is A? Cheppu andarki cheppu. So I can simply say, sir, for the first capacitor, distance between the plates is d by 3 and area is d. So what can I simply write? C1 is equals to A epsilon naught by D, but dielectric is there, so K1 A epsilon naught by D ante kada. You can simply write K1 A epsilon naught by D. D ante D by 3 ra. D by 3. So that means 3 K1 A epsilon naught by D. It is my value C1. ఇప్పుడు C2 గురించి చెప్పురా. C2 అంటే this capacitor చెప్పండి. Directly I am writing 3K2 A epsilon naught by D, and similarly C3 is 3K3 A epsilon naught by D. అంతే కదా. Now when they are in series, what should we write? When the capacitances are in series, 1 by C net is equals to 1 by C1 plus 1 by C2 plus 1 by C3. అంతే కదా. చెప్పండి. So can I simply say D by 3K1 A epsilon naught plus D by 3K2 A epsilon naught plus D by 3K3 A epsilon naught. What you can take common is D by 3A epsilon naught. You can take common 1 by K1 plus 1 by K2 plus 1 by 1 by K3. ante kada. It is 1 by K net formula. Reverse it. Cheppu. What you get? K net is equals to 3A epsilon naught by D into 1 by K1 plus 1 by K2 plus 1 by K3. ante kada. Yes. Good. One more question ra. చూసుకోండి. So if this is my capacitor, అందరికీ అర్థం చేసుకోండి. దీంట్లో I have to add dielectrics రే. కానీ this time I'm going to add dielectrics in this way. So ఇది నా first dielectric. ఎక్కడ వచ్చి ఇది నా second dielectric. Okay, this is my second dielectric ra. Okay, the third dielectric will look something like this. Okay, ఇది నా third dielectric and this is my fourth dielectric. చెప్పండి అందరికి. అంతే కదా. Let us take the values as K1, K2, K3, K4. ఇప్పుడు చెప్పండి. These four could be treated as independent capacitors kada. Yes, very good. So these four could be treated as independent capacitors. So what should I write? C net is equals to C1 plus C2 plus C3 plus C4. ఇప్పుడు చెప్పండి. Total area was A, but I have distributed this total area into 4 parts kada. So area becomes A by 4, ఇది కూడా A by 4 and ఎక్కడ కూడా A by 4. అంతే కదా. Length is D only. Distance you take distance as D only. చెప్పండి. C1 value ra. Can I simply say K1 A1 epsilon naught by D ra plus K2 A2 epsilon naught by D plus చెప్పండి K3 A3 epsilon naught by D plus చెప్పండి K4 A4 epsilon naught by D. But coincidentally A1 A2 A3 A4 all are A by 4 only. So take out all of them common ra. So A by 4 epsilon naught by D into K1 plus K2 plus K3 plus K4. ante kada. So this is my net capacitance. I hope you are able to understand. Or you can also write, you can lay the chudandi net capacitance is equals to A epsilon naught by D into K1 plus K2 plus K3 plus K4 divided by 4. Ante if they are in parallels, net capacitance is A epsilon naught by D into K average. Ante kada. This is the net capacitance of the capacitors. Okay, sir. Antera. If you're done with this, then there is actually nothing. Okay, you take one question now. Final question. A capacitor has a dielectric. Dielectric as shown. Full stop. Find the new capacitance if the old capacitance was C. చూసుకోండి. So this was my initial capacitor. Capacitance was C. కానీ into it I have introduced. So into it I have introduced one more capacitance, but the dielectric constant is K and the thickness, right? Okay, and the thickness, total distance was D, okay? Total distance was D, total distance was D. Area of the plates was A, but now it is D by 2. It is D by 2. Cheppandi. So it is as if the two capacitances are in series, kada? You can directly say C net is equals to C1 C2 divided by C1 plus C2. Ante kada? C1 is C only. Cheppandi. Or you take it as a homework question, okay? You can take it as a homework question. Take it as a homework question, and in case if you have any doubts, you can feel free to ask me, okay? So I think we can stop here, all of you. So, export. Okay. Bye, bye, bye. Good night, good night, good night, good night. Good night. Okay.